All right, so on the back side of the homework, we've got mixed problems. And so you've got to decide, is it ionic or is it covalent? And that will change the way you answer it. So number one is SO2Cl2. So what I'm first thinking is sulfur. Is this a metal or a nonmetal? Well, let me pull up a periodic table, right? Okay, so sulfur is right here. This is a nonmetal. It's on the right side of the staircase. Oxygen's our next one. Oxygen is also a nonmetal. And then we've got chlorine. So chlorine is also a nonmetal. If we've got all nonmetals, these are covalent bonds. So this one right here is going to be covalent, meaning it will share electrons. So if it's going to share electrons, we're doing the bonds with the lines, not the where we're transferring electrons. So we have to decide which one will go in the middle. So if we can pull that back up, if we look at these three, this is sulfur, oxygen, chlorine. The most electronegative is fluorine. Oxygen is going to be more electronegative than sulfur, and so will chlorine. So sulfur has to go in the middle. Hopefully you started to realize that the first element is usually going to be in the middle. So that's sulfur. Let's put 2 oxygens around it and 2 chlorines. So we're doing a covalent structure. We need to know how many total electrons are we sharing. Sulfur, let's see if we can pull that back up again. Sulfur is in the 6th period. 1, 2, 3, 4, 5, 6. I meant 6th group, not period. So it's got 6 valence electrons. Oxygen's in the same group, so it also has 6, and there are 2 of them, so that's going to be 12. Chlorine was in the 7th group, times 2. So we've got 12 plus 14, that equals 26, plus 6, this is 32. All right, so the point of bonding is that we get 8 valence electrons. So everything here needs 8 valence electrons. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Last step is let's check our work. Do all of these electrons add up to 32? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So that is the correct answer to number 1. Let's go and do number 2. CaO. So let's pull that periodic table back up. Hopefully we're... So Ca is right here. This is on the left-hand side of the staircase. This is a metal. So Ca is a metal, and O is a nonmetal. If we've got a metal and a nonmetal, this is going to be an ionic bond. We are transferring electrons. So this is going to be totally different. So let's draw our 2 elements here. We've got Ca and O. Actually, let me go back a step real quick. Okay, so let's pull up that periodic table. Ca is in the 2nd group, so it's going to have 2 valence electrons, and oxygen has 6. So let's go right here. Ca has 2 valence electrons. O has 6. 1, 2, 3, 4, 5, 6. Okay, so what we can see here is both of these need octets. So the way we do that, this one goes here, this one goes here. What our answer is going to look like is Ca has lost 2 negative electrons, so it's got a positive 2 charge. Oxygen has gained 2 electrons, so it went from being 6 valence electrons to having 8. And when you gain 2 negative electrons, your charge is negative 2. So the reason I did these on the same page is now you can see the first decision you need to make. Do we have ionic or do we have covalent? Ionic is where we're sharing electrons like this. Covalent, oh wait, let me back up. Covalent is where we are sharing electrons like this. Ionic is where we are transferring an electron to one atom, from one atom to the other. So there's no bonds, there are no lines over here. We've just got positive and negatively charged atoms holding each other together. All right, so we're going to do numbers 3 and 4. So 3 was BAF2. Number 4 is going to be CCl4. So a helpful thing is before you even do a whole set of problems is to think, all right, is this ionic or covalent? So I'm going to pull that periodic table up. All right, Ba, I see over here that it is a metal, and I see that F is a nonmetal. So metal plus nonmetal. This one over here is going to be ionic. Here we've got carbon, that's a nonmetal. Chlorine, nonmetal. So in these two examples, we're going to have covalent. All right, so again, I'm going to do these next to each other so we can keep getting into our heads that idea that ionic, we're going to transfer electrons, covalent, we will share. So for this one, I'm going to put barium and fluorine. I need to know how many valence electrons we have. Barium's got 2 because it's in 1, 2, the second group. Fluorine's 1, 2, 3, 4, 5, 6, 7. So 1, 2, 1, 2, 3, 4, 5, 6, 7. So I'm going to take one of these electrons and move it right here. What you can see is that fluorine's happy. It's going to have its octet. But barium's still got an extra. That's why this formula up here shows us that there are actually 2 Fs. 1, 2, 3, 4, 5, 6, 7. So this electron is going to go right there. So we're going to have Ba, which has lost 2 electrons. So that's Ba plus 2. And then fluorine. Each of these gained an electron to now have 8 valence electrons. You can see how terrible those valence electrons are. Okay, now when we do the charges, if fluorine only gained 1 electron, then it's -1. But each of them are -1. So -1 plus -1 is -2. That -2 charge cancels out that +2. All right, I'm going to draw a little squiggly line here to separate these. All right, so there we were showing a transfer of electrons because it was ionic. But this one we know is covalent. It's nonmetal plus nonmetal. So which one goes in the middle? Well, if we look at the periodic table, carbon's here, chlorine's here. Carbon's going to be less electronegative. Also, carbon always goes in the middle. So it's a pretty easy rule, just remember that. Okay, so the point of bonding, everything needs an octet. We were focused on that over here, giving everything an octet. We're also focused on it here. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Now we need to count up our total number of electrons. Carbon has 4. Chlorine has 7. But there are 4 chlorines, so 7 times 4 is 28. 28 plus 4 is 32. Let's count them up. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. There we go. Okay, so what you're hopefully seeing now is the rules are very, very similar. The focus is we're transferring electrons in ionic bonds, and we are sharing them in covalent. I'm going to do the last 2 very quickly. All right, so HCN, oops, I guess I need to make that a color. HCN. Okay, when I look at that, hydrogen, nonmetal, carbon, nonmetal, nitrogen, nonmetal. If these are all nonmetals, it's going to be covalent. Okay, what goes in the middle? Well, hydrogen can't go in the middle. Nitrogen or carbon, carbon is less electronegative. Also, carbon always goes in the middle. All right, I need to count up my electrons. Hydrogen, that brings 1 to the table. Carbon's got 4. Nitrogen's got 5. Total, 10. All right, I would give hydrogen an octet, but hydrogen can only hold 2 electrons anyway. So this is 2, 4, 6, 8, 2, 4, 6, 8. Let's count up the total now, see if it matches. 2, 4, 6, 8, 10, 12, 14. That's way too many. So what do we do when we've got too many? We've got to think about double bonds. So those 2 lone pairs, we're going to get rid of them, and these 2 atoms are actually going to share them. Let's count up our total electrons. 2, 4, 6, 8, 10, 12. Still too many. The problem is we're going to make, or rather the solution is, we're going to make one more extra bond. If I cross out those 2 electrons and share them, we've got 2, 4, 6, 8, 10. The question that you might be thinking is, why didn't we put a double bond on hydrogen? Hydrogen didn't have any lone pairs to share, so we had to go for a triple bond between carbon and nitrogen. All right, last one. This is BeBr2. We can see that Be is a metal. It's right over here. It's got 2 valence electrons, and Br is a nonmetal. Metal plus nonmetal, this is ionic. Okay, Be, we've got 2 valence electrons. Br, we've got 1, 2, 3, 4, 5, 6, 7. We see this 2 here, so we know there's going to be 2 of them. 2, 3, 4, 5, 6, 7. This electron's going to go there. This electron's going to go there. Be gets rid of both of its electrons, and now Br's got 1, 2, 3, 4, 5, 6, 7, 2, 4, 6, 8. This one had 8 as well, excuse me. So I kind of ran out of room here, so I'm going to draw the line, but I'm going to put the answer down here. Be, it lost 2 electrons, so it's positive 2. Br has its octet, so it gained 1 electron. That's negative 1. Same deal here. Everything's got an octet, plus 2, and then a minus 2. We're good to go.